Okay, so let's talk about the structure and functions of your lipids. Alright, here we go. There's actually at least three different types of lipids. One is cholesterol, and you have phospholipid. But for this unit, we will only be concentrating on triglycerides. Triglycerides, also known as fats and oils. We will talk about phospholipid when we reach the topic of the cell membrane. So for this 2.3, we just want to focus on triglyceride. So from the word itself, tri meaning three, and glycerides, this actually means that your triglyceride is made up of three fatty acids that are linked to your glycerol molecule. And let me show you the structure. So you have here your glycerol molecule, and you have 1, 2, 3 fatty acids. And in the process of condensation, we remove water, so that's 3 water molecules removed to be able to form an ester bond between your glycerol molecule and your fatty acids. Now, the fatty acids making up your triglyceride could either be saturated fatty acid or unsaturated. And your unsaturated fatty acid can either be monounsaturated or polyunsaturated. Now, quick review. So your fatty acid structure is, we call it a hydrocarbon, so it's basically made up of carbon and hydrogen. So all corners are hydrogen, and you end it carboxylic end. Saturated means this molecule is saturated with hydrogen. So there's nowhere I can add another hydrogen. It's all completely filled up with hydrogen. For your unsaturated, it means there are some portions in your hydrocarbon chain where you find a double bond, and this position right here means 1, 2, 3, 4, 1, 2. Means that you can still remove the double bond right here and add hydrogens. That's why it's unsaturated. It doesn't have, it's not yet completely filled up with hydrogen. You can still fill it up. So if you find one double bond in the hydrocarbon chain, you call it a monounsaturated molecule. But if there's more than one, then it's a polyunsaturated fatty acid. Alright, another structure that you need to know are under your unsaturated fatty acids, the molecule can take a cis or a trans structure. Cis is when around your, in that portion of your hydrocarbon chain where you find the double bond, the hydrogen are found on one side, like this one. Trans means across, Trans-America. If that portion of your hydrocarbon chain where you find the double bond, the hydrogens are found in opposite parts of the chain. So you have hydrogen here, and you have another hydrogen here. So they still both have double bonds. It's just the position of the hydrogen around the carbon where you find your double bond. This structural difference has a big impact actually, because this molecule right here can easily be bent. However, trans configuration is harder to bend the molecule. Therefore, this one will actually have a higher melting point than your cis unsaturated fatty acid. And this normally remains as liquid in room temperature. Let me put oil. And then this remains, it actually becomes solid at room temperature. And this is actually a product of partial hydrogenation of your oils. And we actually use this in industries because now we know that it has a higher melting point. It is solid in room temperature, can actually be used to provide longer shelf life for processed food. So where do we find this? Go ahead and buy your chips. Look at the label on the back. It will have trans fats or any kind of processed food that uses transferification or partial hydrogenation of its oil means it can have a longer shelf life. So it's actually good for the food industry. So we are familiar with the basic structure of the different lipid molecules, and let's talk about their function. There's actually two things that we want to talk about. First, let's start with the good functions of your lipids, and maybe we can end with the bad about these lipid molecules. So the good, I'll use a blue pen. What's good about the lipid molecules? Well, it is a good source of energy. In fact, a molecule of lipid contains more energy than carbohydrates. Another one, for insulation. Lipid molecules are not conductors of heat, so they can keep the body insulated. Animals in the North Pole, they will need that to keep them warm. Our internal organs are also surrounded by lipid molecules for insulation. What else? And it does not just provide insulation to your internal organs, but it can also serve its purpose as a shock absorber. Okay, so those are the good. Now let's talk about the controversial issues surrounding lipids. We all know, I'll use a red pen, that lipids has a very bad reputation. Talk about lipids, you talk about fats, you think about cardiovascular heart diseases, CHD. So we have to analyze, first of all, there seems to be a correlation between increased consumption of saturated fats and the development of heart disease. But there are also some examples where it doesn't show any correlation. For example, the tribe in Kenya, the Maasai tribe, they eat diets rich in fats, meats, oil. However, it's very rare to find an incident of cardiovascular heart diseases in the tribe. The opposite example mentioned by the book was so countries in the Mediterranean, they always use olive oil in their diet, so that could have led to low rates of cardiovascular heart diseases. However, their food is also rich in tomatoes, and this can explain why they have lower rates of cardiovascular heart disease. It might also be genetics, so they are not genetically predisposed to develop cardiovascular heart diseases. But what I'm trying to say is, we are trying to establish a correlation, and it's not really a cause and effect relationship. However, it can be causal, and we have to base that on an experiment. So, what we have found out is that patients who have died of a cardiovascular heart disease, according to studies, have higher levels of trans fats found in the linings of their blood vessels. So maybe we can establish a causal relationship, but majority of the health claims that we know right now are establishing correlation. And if there is a correlation, we have to look at analyzing the the many experiments or surveys done to establish these correlations to be able to actually obtain more evidence and a stronger correlation between our health and how is it correlated to our consumption of high-fat food. By the way, this also would lead us to the concept of the body mass index. Quickly here, I'll end with body mass index. This is a quick way to look at, to give a rate of a person's health. BMI can either be calculated. If you calculate it, this is weight in kilograms over height in meters squared, or you can use a nomogram. So if you calculate it, you'll get a number. If you use the nomogram, you also get a number. And what do you do with that number? Let me show you a table of interpretation for BMI. Okay, so here's an interpretation of a number. You can see this in your textbook. After using the formula, after you calculate, check against this table whether to categorize a person as normal, overweight, underweight, and etc. These are the other levels using the table. Let's look at a nomogram. Okay, this is a Google image of a nomogram. So you plot, you look for your weight here, kilograms, and your height. And then you can use a ruler if you want to connect your weight to your height, and then look at the number where it intersects this BMI index right here to get the value for your BMI. Alright, so that's all for Lipids 2.3.